Good morning, all. This is Unit 1 Portfolio Construction, and the topic is Sharpe's single index model. And we are dealing with the problems in Sharpe's single index model. So, coming to the second problem in Sharpe's model, let us see the question. From the following information, calculate portfolio return and risk. Assume market return of 15% and market return variance as 3.2. So here you have to find out the portfolio return as well as risk. Market return is given, it is 15%, and market return variance is also given, that is 3.2. So first head is security, then we have weights, then alpha I, beta I, and standard deviation EI square. So we'll see here we have different securities, that is 4 of the securities we have A, B, C and D, and their weights are given. Then alpha values of the individual securities and also the beta values are given, and the standard deviation EI square is also given. So that is nothing but here, that is the unsystematic risk, that is also given. So we'll see the solution. So coming to the formula here, return on portfolio is nothing but it is Rp is equals to alpha p plus beta p into Rm. Here you have to find out the alpha p. Alpha p is nothing but it is risk-free return. So risk-free return can be calculated using summation of xi into alpha I, that is individual securities. You have to take weightage of weights of individual security into alpha values. So that is given in the question. Coming to the solution, here we have RP formula. RP is equals to alpha p plus beta p into Rm, that is written on portfolio. So alpha p you have to find out. Portfolio, it is the expected return on portfolio. For that you have to find the summation, or you have to add all the individual stocks. Summation of weights into individual stock rates. So here we have 4 securities, that is A, B, C and D. So their weightage is given in the question. So that is weights are given, that is 0.2, 0.1, 0.4 and 0.3 for 4 securities, and also alpha values is also given. So take those values. So weight into alpha values, that is rate of the individual securities. So 0.2 into 2, 0.1 into 3.5, 0.4 into 1.5, then 0.3 into 0.75. So by doing the product of these values, you are going to get these rates for individual securities. So then the thing is, you have to summate these values. Here you have to summate the values. So if you total it, then you will be getting it as, this is 5, 7, then again 10, 13, 15. So this is 5 again. Here it is 1. So 1.575. The value is 1.575 here. So the total value is 1.575. Next, so here you have to find out the beta also similar in the similar way, that is written on portfolio for beta is equals to summation for individual securities. Here you have to take weightage into beta values. So same way you have to do for 4 securities. So by doing the calculations you are going to get it as 1.06. So now the thing is you have to substitute it in the formula, that is Rp is equals to alpha p plus beta I into Rm, that is equals to alpha we have found out, that is 1.575, plus beta values of various stocks we have found out, that is 1.06, into market return. This is given in the question. So 15% is given in this is in the question. So that value we are substituting here. So by doing the calculation you are going to get it as 17.475%. So this is a return on portfolio. So next one is we have to go for risk part. So risk on portfolio we have to calculate. So here risk on portfolio, the formula is standard deviation p square is equals to beta p square into standard deviation m square plus standard deviation ep square. So in the previous slides I have given the formula of risk on portfolio. So just if you look into the formula, then it is a standard deviation p square or I square. If it is individual, then we'll go for I. If you want to find out the portfolio, that is a group of stocks, then we will be placing it as P, uh, sigma P square. So here, so this is nothing but variance. So variance of the portfolio or variance of the individual security. Then here beta P square is nothing but it is systematic risk. Then sigma m square, it is variance of market. So whenever you are getting it in a square, then it is nothing but it is variance. So variance of individual security and variance of the market. So all these things are there. So here standard like sigma ep square is nothing but this is the unsystematic risk, which is unique for the organization, which is unique for the firm. So that should be taken. So here as the value is given in the question, so this is also considered. Here you have to take so this formula if you see, then it is nothing but total risk. Total risk is nothing but it is systematic risk and unsystematic risk. So this part will be the systematic risk. So beta p square into standard deviation m square, this part will be the systematic risk and this will be the unsystematic risk. So total risk is equals to systematic plus unsystematic risk. So systematic risk if you see, then it is nothing but variance of market and variance of that is systematic risk into variance of market. So here this is unsystematic risk. So as it is related with the market variance, you have to multiply it with the systematic risk, that is market, it is related with the market risk. So here you have to find out the unsystematic risk, again you have the how you are going to find out, that is nothing but it as it is unique or uh, it's identical for the organization. So you have to take the weights. So here weights of the securities, weights of the individual securities into unsystematic risk. So unsystematic risk, it is given in the question again. It is 3 point market return variance. It is given in the question. Here unsystematic risk, it is given in the question, not market variance. Market variance is different. It is for systematic risk. So unsystematic risk, it is given individually for each and every stock. That is standard deviation EP square is equals to weight of the securities, the whole square, into, if you see in the question, it is given, that is sigma EI square. That is nothing but it is the unsystematic risk. So that is 3.70 for first security, for A security. So that is 0.2 the whole square into 3.7 the whole square. Here you have to take it as square. Then same, it is for B security, C and D security, it is same. So you have to take the weights of the individual securities into unsystematic risk. As the weights were given, we have to multiply it with the proportion value of the that particular security. So this is about unsystematic risk. So this part is unsystematic. This is total risk is equals to systematic plus unsystematic. So unsystematic risk, as you have to take the weights of the securities with their values which is given in the question. So by doing the previous calculation, here you are going to get it as 108.45. Then substituting these values, that is to finding the total risk is equals to systematic plus unsystematic risk. So systematic risk, here you have already we have found out the beta values, beta of the portfolio, that has to be squared. Then market variance. Market variance is given in the question, so that value you have to take up. So sigma p square is equals to 1.06 the whole square into market variance, that is 320, plus unsystematic risk. So in the previous slide, this is this value we have got, that is nothing but that is unsystematic risk 108.45. So by doing these calculations, you are going to get it as 468.002. Okay, so it is in square. So you have to find out the portfolio risk. So for that, if you have to get it under root, that is 468.002. So if you square root it, then you are going to get it as 21.633%. This is risk. So square should be taken off. So to find out the total risk, for that you have to put it under square root. Then you are going to get it as 21.633%. So this is question wherein you are going to find out both the return as well as risk with Sharpe's single index model. So hope you have understood this problem. Thank you.